Good morning. Today we have the talk on software engineering. It's a different discipline compared to the traditional engineering which we had. And as the machines take over human activities one by one, there is also associated serious concerns raised. We will look into what are these concerns and what exactly is the reason behind these concerns. The main concerns which we put forward to software engineers is that why there is no guarantee as far as the products of software engineers is concerned. I don't know how many of you feel that there is a guarantee to the products that's basically the software which you use. How many of you feel that? Anybody feels that it is there? Anybody feels that it is not there? Essentially, the talk is with the assumption that we don't get the guarantee which an engineering product, any engineering product must have. And this issue is better put by James Chalmers in his article, which appeared in July 2017, titled The Coming Software Apocalypse. Essentially telling the total destruction of the world due to problems in software. Now, why or what is the concern essentially he's trying to? You young generations may not be aware of the chaos we have gone through the world over due to the year 2000 problem, which we normally call as Y2K problem. People even said that the world is going to end because people were afraid whatever activity that was controlled by software, they were having no clue what exactly is going to happen. And James Chalmers, in his article, is essentially talking about the loss of human lives in automobile industry, specifically in a car, due to an error in software. And recently, I hope all of you might have observed the check-in chaos which we had in the airports, basically because of the software failure. So these are serious concerns. I just mentioned some of them, but the concerns are, or problems are much more with billion-dollar issue, basically. So the question is that, what exactly is wrong? We don't have the guarantee. And why? Or what comes in the way of software engineers essentially to give this guarantee? That's the question. Let's look at that and maybe try to understand what may be the reason. So the first thing is, when we say software engineering, let's look at that term engineering. The first thing is that a graduate that's coming out with a, let's say, BTech degree, should he satisfy that BTech computer science and engineering, let's say, the engineering? So there is a confusion regarding what is he? Is he a scientist or an engineer? Now, but then we have to try to have an understanding what exactly the difference, if at all there is. I feel we essentially made that difference because of some reason. We need it. It doesn't mean that there isn't an overlap between these two. So the better way to, or one of the way to understand the difference is better put like the scientist essentially builds to learn, and the engineers learn to build. Both build, but there is a fundamental difference as far as the building part is concerned. The engineers give a guarantee on the product which he builds. For example, an engineer builds a bridge. He gives a guarantee regarding what may be the load it can withstand with associated things like maybe a frequency change, or maybe the motion of the load, all those things. But those are details. But there is a guarantee. You know that when a civil engineer builds a 100-story building, he essentially gives a guarantee regarding how much Richter scale earthquake even the building will withstand. So any engineering product, I feel there is a guarantee, and that's the fundamental characteristic of an engineer. And when we look at that engineering discipline, let's go into detail so that we understand the characteristics, and let's look at the issue which we essentially started off with. So you can see that any engineering, not only software engineering, has these fundamental stages, which is you try to understand the problem and specify it. Then you have the design stage, followed by finally the development. But somehow, a person who has not gone through a professional training essentially tries to build before spending enough time on problem understanding and design, causing a lot of issues. In the case of software, a lot of errors, which he essentially tried to solve later. And we also know that the solution of these problems in terms of the error in software essentially is done by testing. And Professor Dijkstra has very well put that testing can only show the presence of bugs, never its absence. If you wanted to give a guarantee, testing is not at all the method. Now, let's look each of these engineering stages one by one, a little bit more carefully, to understand what exactly are the issues. It is noted that approximately 50% of the product defects originate in the requirements. And let's see what exactly is the cause or the reason behind these problems in the requirements. It may be due to the requirements being ambiguous. Maybe that it is the specifications given are inconsistent. Or it can be even the case that it's not complete. And in this respect, maybe one of the simplest example is, suppose I wanted to build a house. I may start saying that I need a house, but the builder, he does not get the details. So I go on and add, I need a house of 2,000 square feet, let's say, clarifies things, specifies it further. Goes further as far as the specification is concerned by saying that I need 3 bedrooms, 1 drawing room, 1 kitchen, 1 balcony. So is it sufficient to, let's say, to do a cost estimate as far as this house is concerned? No, nowhere. So he keeps on adding things like the electrical requirements he essentially expects, with maybe the associated company details of the products, which is going to be used, the lightings, and also the plumbing materials. Keeps on adding further. He talks about the material to be used as far as the floor is concerned, the roof is concerned, the walls are concerned. And do you think the specification is complete? Not yet. Maybe there can be issues like you wanted to have a washing machine and you haven't really looked at the space that it may occupy. So whenever you have this specification, unless and until we are careful, there is going to be some defects which will finally come up later into the product, which causes a lot of problems. So normally, as far as specification is concerned, we expect, if you wanted to have this as a serious stage, complete in all respects, we should take the help of domain experts. And domain experts will talk to the client and extrapolate, because the clients may not be in a position to give all the requirements. It may not be. So the client will extrapolate like the space for the washing machine I said. He might ask the client, look, you would like to? Then he adds that. Everything finally says that this is what exactly the specification is. In this respect, maybe I'll try to explain one of my experiences were around 10 years before. So we, 14 faculty members from 14 NITs all over India, gathered in NIT Allahabad for 2 days, starting from 8 a.m. to 6 p.m. We were essentially discussing the specification of IEEE software, All India Engineering Entrance Examination Counseling software. So these 2 days, the National Informatics Center came with a prototype. We discussed, we corrected some of the loopholes, as I mentioned, the issues that may come up. And the result is that this software ran without much trouble. That's the outcome of a serious effort on that. Now, looking at the next stage, as far as engineering is concerned, that's the design. It is felt that the fundamental problem as far as design is concerned, where exactly an engineer get into issues, is when the problem is complex. Or tackling complexity is the fundamental thing when you essentially try to design finally, based on your specification. And in this context, Charles Mingus has put, let me quote that, making the simple complicated is commonplace, but making the complicated simple, awesomely simple, that's creativity. He essentially tells that you have to address this complexity. Finally, you should feel that it is simple, and simplicity is a prerequisite for reliability. If it is complex, the chance of error are high. Simplicity is a prerequisite for reliability. That's the message essentially he is trying to give. And the design stage, so once an engineer has done these 2 stages of requirement specification and the design, look, as far as software is concerned, by the time a design has come out, the engineer has also said that the product essentially meets the specification. That's very important. What normally happens is that we jump to coding and there is no clue regarding the correctness. And in this context, let me try to explain the experience which we had in a course titled The Foundations of Programming in the 3rd semester in our institution, where when it comes to the evaluation stage, we use that 3 stages which I mentioned earlier. The students in the 3-hour slot, 10 minutes, we give the problem and we say that that's for problem understanding. Any issue you can ask, make sure that you are clear. Don't say later, I thought the problem is this and hence the writing like this. No excuse. After that 10 minutes, we give him or her 1 hour to put down the design through which we can check that his solution is correct. And only after that, we essentially send the student to the laboratory. And the outcome is that we found the students who have seriously gone through the specification and the design stage came out of the lab in 30 minutes. But it's not that they came out in 30 minutes that's important to me. I'll say that the most important thing is that those students were confident that the programs were correct. They even say that, sir, you give any input, it will give the correct output. Design and specification finally leading to the requirement of an engineer. That is, it is correct. I'm not getting into the details of how exactly that correctness proof, etc., is done, but doing it properly is a mandatory thing to have the final reliability an engineering product must have. And finally, taking that design to the final product, it is essentially programming as far as software engineering is concerned. And even here, it seems there is sort of confusion or not proper understanding what exactly a programmer is supposed to learn, whether he is supposed to learn programming or a programming language. And here, the shocking thing is that when I see many of the CVs of BTech students, computer science students, I see the student claiming 4 to 5 to 6 programming languages as its skills, but nothing on programming. That's a shocking thing. What exactly a student is supposed to do? Learn programming or programming language. So note that we say learning astronomy is not the learning of telescope. So people essentially have this fundamental misconceptions through which essentially we get into trouble. And if you finally come to the education sector, what exactly we do in engineering institutions? Here again, there is a problem regarding the understanding of the discipline and associated issues. If you look at, normally the degree is termed as computer science or computer science and engineering. Now the question is that whatever we claim as BTech in computer science and engineering, what we are supposed to learn, is it computer, within quote, science, or computing science? When we completed the curriculum development in 2010, clearly specified that our students are not expected to have any contribution in hardware. We were perfectly clear, it is computing science, the software on top of the hardware. That clarity, or that there is a misconception even in education which can cause a lot of damage. And here, finally, let's come to the issue which was raised at the beginning. Is it really going to be the case that we are going to have a software apocalypse? Let us hope that the concerns raised by the author was essentially coming from his thought as a pessimist. But then, we should not forget or ignore the concerns raised, and we should not avoid addressing them. Thank you very much.